These are your 6-1B notes, composition of functions. In this section, we're going to learn how to find the composition of functions. It's a new operation, and we're going to learn how to write simplified functions using composition. So before we begin, I got to define what a composition of functions is. And it's when the range of one function is found using the other function as its domain. So you're plugging in one function into the other function. A good example of this would be when you go shopping and you have to apply a discount and then you have to apply sales tax. You would plug the original price into the discount function, figure out your new discounted price, and then you would use that price to figure out taxes. And so that would be a function within a function. It's a work in progress. The symbol for composition is an open circle. So kind of like a multiplication dot, except it's not a dot, it's the actual open circle. And I'm showing you a variety of ways that the book likes to illustrate composition. Sometimes they put brackets around the composition. Sometimes there are no brackets at all. My favorite is taking the open circle and writing it as nested parentheses. So I get rid of the open circle altogether, and in that particular notation here, you can actually see that you're going to evaluate the f of x function in terms of the g of x. So you're plugging the g of x function into the f of x function. And how you read that is f of g of x. So in my shopping example, x would represent the original amount for the thing that you're buying. G of x would be the function that takes away and gives the discount. And f of x would be after the discount is applied, it would apply the tax to that item. So when you work through these, I just want to make a note. You either work backwards. I like to think of backwards through the problem, or inside out. If you have those nested parentheses, you're going to work with the innermost or the last listed function. So if you look at my rules here, I just want to point out that when we talk about the evaluation process, I'm setting it up in terms of F composition G. So if you see this problem, F composition G, you would evaluate G first, working backwards through the functions or inside out. And what I mean by inside out, that really is f of g of x. So you'd work through this function first, then work through the f of x function. It's not always that g is first, it's just the order in which they're listed. So again, I'm referring to the order in which I listed it in those instructions. So the domain would be x. What you get is your range for g of x, and then that range becomes your domain for the f of x. So little play on words, domain, range, input, output, x and y. They all mean the same thing. So let's go ahead and try this with the number 5. I think numeric answers make a little bit more sense. I'm actually going to ask you to find two functions, or two compositions, f composition g, and then we're also going to find g composition f. That's how your homework's set up too. They want you to find both. More importantly, I know you can get the right answer, is I'm worried about the order. Is your answer in the right spot? Order is definitely important here. So if I'm going to find f composition g, I'm going to write that down, f composition g, and my x value that they want me to find this for is 5. F composition g of 5. If I write that as nested parentheses, it looks like this, f of g of 5. And it really, if you work inside out, I'm going to plug 5 into the g of x function and get an answer. And then I plug that answer into the f of x function. So the very first computation I need to make is g of 5. You guys have worked with function notation before. G of 5 means plug 5 into the g of x function. So replace the variable x with 5. 2 times 5 minus 7. 2 times 5 is 10. 10 minus 7 is 3. So g of 5 equals 3. Okay, now I'm going to take that 3 and find f of 3. So f of 3 is function notation for plugging 3 into the f of x function right here. So wherever I see the variable, I'm going to replace it with 3. And f of 3 is equal to 8. So that's a function within a function. I plugged 5 into G and got 3. I plugged 3 into F and got 8. And so how we write our answer is F composition G of 5. When I plug in 5, the composition gives me 8. So we basically skip over the 3. We don't really worry about the 3. That's that midway step. Okay, in the other format, if I want to do the same problem but now do G composition F, there are times where it's going to give us a different answer. So we're going to do G composition F of 5. Write it as nested parentheses. That's G of F of X. You can see the F of X sitting in there, and actually I can make that a 5, sorry, F of 5. And it says, let's find F of 5 first, then take that answer and plug it into the G of X function. So F of 5 is replacing the variable in the F of X function with 5. So that's 5 plus 5. F of 5 is equal to 10. Now I'm going to take that 10, which is F of 5, and find G of 10. So G of 10 is equivalent to 2 times 10 minus 7. That's 20 minus 7, or 13. So my solution, G composition F of 5, is 13. When I take the composition G composition F of 5, I get 13. I got 10 in between there, but we don't even mention the 10. We just sort of skip over it. 5 gave us 10, 10 gives us 13, therefore 5 gives 13. And that's G of F of 5. Order definitely matters. We're going to skip the -3 example. And so now what I want to do is come up with an equation that I could use in case I wanted to find 5, 4, 3, 2, 1. If I want to find multiple numbers, I don't want to have to go through that work twice. I'd rather have one function that works for the composition so that I just have to plug the number into that function. So how you do this is the same thing we just did, except instead of plugging in 5 into the other function, we're going to plug the entire function into the other function notation. And then you just clean it up. You multiply, you square things, you do all the wonderful stuff. So again, we're going to find both F of G and G of F. So F of G, F composition G, is the same thing as F of G of X. And I'm going to take it a step further. Notice I don't have a number to plug in there. But G of X is sitting inside my F of X parentheses. I'm going to take this G of X function right here, and I'm actually going to plug it in and replace G of X with 2x minus 1. So I'm going to write the same function notation as F of 2x minus 1. We're finding the function F in terms of G. The G of X function is 2x minus 1. So in this F of X function here, wherever I see the variable, I'm going to replace that variable with 2x minus 1. Replace the variable x with the G of X function. So what this becomes is 3 times 2x minus 1 squared. There's my 3x squared. Minus 2x minus 1. There's the minus x, and then plus 4. So there's my F of X function in terms of G of X. Now all it requires is some cleaning up. So I need to square this 2x minus 1. I'm just going to write that down because squaring just means to multiply by itself. So I have those two quantities. And then I'll eventually have to distribute a negative through that second quantity. So by rewriting it this way, I took care of the squared. That's what squared means. I got to leave the 3 on the outside because I need to square this before I can multiply by 3. So FOIL, 2x times 2x is 4x squared. Outside would give me a negative 2x. Inside gives me a negative 2x. And last gives me a positive 1. I'm going to distribute the negative through the second quantity, minus 2x plus 1, and then don't forget the plus 4. So I'm going to clean this up before I multiply the 3 through, so just keep the 3 there. I get 4x squared minus 4x plus 1 minus 2x, and I can actually just put those together and call that plus 5. So now I'm going to distribute 12x squared minus 12x plus 3 minus 2x plus 5. One more step of cleanup. So I'm going to put my label. This is f composition g of x is equal to 12x squared minus 14x, that's putting these two together. And then if I put the two numbers together, it's plus 8. And there's f composition g. Now g composition f is just the reverse order, and it's actually not as involved. So I'm just going to show that one up here. So g composition f would be g of f of x. You can see f of x sitting inside the g function. So I'm actually going to take this whole function f of x and plug it in there. Call that g of 3x squared minus x plus 4. And what that is saying is I'm going to replace the variable in the g of x function right here, that x, with that trinomial. So what this becomes is 2 times 3x squared minus x plus 4 minus 1. There's your 2x minus 1. Clean it up. We're going to distribute the 2. 6x squared minus 2x plus 8 minus 1. The only thing I have to do is combine those two numbers. So g composition f is equal to 6x squared minus 2x plus 7. And there you have it. That's what we're doing today. So for your lesson summary, I want you to find the value of f composition g of 4 using those two functions. And then using the same two functions, I want you to write a simplified function, f composition g. So in the lesson summary, you'll have a number as your answer, and in the practice problem, you'll have a function, you'll have variables in your answer. Good luck.